Hey guys, today we're talking about scientific notation. Scientific notation allows us to write really, really big numbers and really, really small numbers in a way that allows us to see the number a little bit better. So, our normal way of writing numbers is called standard form. If we want to put a number in product form, we take and we find the number that we could use as our ones place. So you go the furthest to the left until you have only one number in the ones place. That would be the 3. And then you place a decimal point there. Then you decide how many spots you would be multiplying by to get it back into its original form. So 3 25/100 times 100,000 would give us this 325,000. So now we can put it in standard or in scientific notation. In order to do that, we take our 325 and we leave him and we multiply instead by a 10, and this 10 would be to the 5th power because there is 5 zeros in 100,000. So, because 10 to the 5th power would be like taking 10 times itself 5 times, which would give you 100,000. If it's a really small number like here, we still move the decimal point until we only have one number in the ones place. It can't be 0. So we're going to move it 4 spots to 5. Since we moved it 4 spots, we would be multiplying it by 1 10,000th. So we count and we look, okay, I moved it 1, 2, 3, 4 spots, so it's 5 times 10 to the negative 4th power. A number written in scientific notation has to have a base number that is greater than or equal to 1, but has to be less than 10, which means it cannot be 10, it has to be less than 10. So if it's a decimal, it could go all the way up to 9.9 repeating, but it can't ever reach past that to get to the 10. Okay, then, oops, I didn't mean to hit that. Sorry about that. So now, if we look at this, it has to be a base of 10 to the power of some number. So here are some examples and non-examples. 3 5/10 times 10 to the 5th power is okay. Over here, 4 is not okay to have as a base. Here, 6 89/100 times 10 to the negative 3rd power. The 10 to the negative 3rd power is fine, but this decimal point needs to be here and not, we can't have two numbers because that number is not between 1 and 10. Here we have 2 times 10 to the 7th power. Here we don't have a number that is between 1 and 10. So be careful with that. All right, so let's practice some of these. Changing to scientific notation. So we're going to take for this first one, and we're going to make sure that we move our decimal point behind the 4. So we want it to end up being 4 point, well, really nothing because we don't have any other numbers. So just 4 times 10 to some power. Now, this is a small number, so we have to make sure that he gets smaller through multiplication of 10. So that's why we need it to be a negative. And we've moved it 2 decimal places, so it's to the power of negative 2. Okay, this is again another small number, and it's getting bigger through scientific notation. We're looking at it as an 8 9/10. I've moved my decimal point, so it's really times 10 to the negative 4th power. Here, it's going to be a bigger number and getting smaller, so we have to make him a bigger number by multiplying by 10, but we're multiplying it by 1, 2, 3, 4, 5, so 10 to the 5th power. Here, I'm going to make him 7 39/100, and I'm moving it 3, 6, 9 places. So this is why it's 10 to the 9th power. Here, it's going to be 5 2/10, and I'm going to move it. I like counting in 3s for some reason, so I count, especially because that's where we put our commas usually. So 3, 6, 7, 8 places. So times 10 to the -8th, because it's going to be getting smaller. Here, it's going to be 2 74/100ths. So I'm moving it 3, 6, 9, 10, 11 places. So times 10 to the -11th. Go ahead and try changing these. Actually, I'm going to show you how to change these to standard form. I'm sorry. So 2 times 10 to the -4th power. So if it's in scientific notation, our decimal point would actually be behind the 2, and we're going and making him smaller. So it's going back 1, 2, 3, 4 places, and then the decimal point. So 0 and here I would need a 0, here I would need a 0, and here I would need a 0 before the 2. So 3 zeros and then the 2. Here my 84 would be at the end, and I'm moving my decimal point 1, 2, 3, 4, 5 spots, and then the decimal point. So that's where I get my 84, and this would be the millionths place. All right, for this one, it would be the 631, and I'm moving it 1 already. So 7 more places, and then my decimal point. Here, I would be moving it 1 place to get it past the 7, and then 2 more for the 3, and then my decimal point. Here, I would be moving it 1, 2 places for the 19, and then 3 additional for the remaining of the 5. So this is getting bigger. Same with this one. I would move it 1 place for the 5, so 5 additional zeros on the back end. Let's look at a real world example. This right here is science to a T. The maximum distance from Earth to Jupiter is this crazy big number. What is it written in scientific notation if it's 968,100,000 kilometers away? See which one you think you should pick and why. Okay, I personally would definitely eliminate A because this number is not between 1 and 10. Same with B. So these two numbers are between 1 and 10, but he's a crazy big number. He's a crazy small number, and he's a crazy big number. So that is why my choice would be C. 1, the base always needs to be 10, and that works, but our number that we're multiplying by has to be between 1 and, it has to be greater than 1. Let's rewrite this. Our number has to be greater than 1, but he has to be less than 10. Can he be equal to 1? Yes, he can be greater than or equal to 1. So x can be greater than or equal to 1, but he's got to be less than 10. So can he be 10? No. A flash of light consists of 3 or 4 strokes. The time between each is, if we look at this, tenths, hundredths, thousandths, 10 thousandths, 100 thousandths, so 500 thousandths of a second. Let's write this in scientific notation. So we know it's going to be 5 times 10, but it's a smaller number and it's moving 1, 2, 3, 4, 5 places. So 5 times 10 to the -5th power. If we're looking at our calculator, if we look at our iPhones or iPods versus our Texas Instrument calculators, we're going to see different numbers. When you calculate and you multiply 2 values and you see this is scientific notation. It's just written a little bit differently. So what this number really means is 625 and then 10 more zeros. 3, 6, 9, and 10. Okay? Over here, if we see it, it's got a little times 10 to the 12th power. It's a little bit easier to see on our Texas Instrument. So you have this crazy number, and it's times 10 to the 12th power. So it is written in scientific notation. How many times larger is this number than this number? Let's take a look at this. If we actually write it in standard form, 3 and 5/10, and we would need 3 more zeros behind it, versus 500. So how do we figure out how many times larger he is than him? We're going to divide. So if we take 35,000 and we divide it by 500, we get 70. So he is 70 times bigger. Go ahead and try this one for me, and I'll be back in just a second to show you what I did. So if we have 1 and 5/10 times 10 to the 3rd power, we really have 1,500. If we have 2 and 5/10 times 10 to the 2nd power, we really have 250. So if we divide those, 1,500 divided by 250 gives us 6. So he is 6 times larger. You will see ones like this on assessment, so be careful. And I will see you next time. Have a great day.